So we have been 30 years in operation. And this is where we are located. This is the building, and if you look closely, you can see the logo on the wall there. Do you see it? So it's not a fantasy. It's not AI. It's not Photoshop. It's actually real. And we operate as a CRO. This is a contract research organization. So we develop, we validate, and we apply analytical methods for different purposes. So this includes the research on obesity and related diseases like diabetes and coronary heart diseases. Also, dementia and Alzheimer's and cutting-edge biomarker to forecast this disease 10 years before system onset. We work with babies, newborns, premature babies, and we work with companies that develop new drugs. So, in addition to being CEO of this company, I am also the Chief Scientific Officer. I have a PhD. I do research, I do science, I publish papers. And these are some of the recent papers that we have published. And you will see from the blue bold headings that it's related to diabetes and obesity, to inflammation, biomarkers for inflammation, and dementia and Alzheimer's. And it's also risk stratification for coronary heart diseases and biomarker for this, including vitamin D. And you know, these scientific papers, they are published in scientific journals, and they come in good and bad, as most things in life. And these are some of the journals that we publish in, and the impact factor is behind there as a number. And I would say a good journal would have an impact factor of 5 or more. And then you see these scientific journals, 6, 15, and 105. And I'm quite sure that those in the room that are scientists that know this journal will confirm that these are top-notch publications. So, thank you. And the people we work for, they are also top-notch. I mean, in addition to Dag here, we have testimonials from our collaborators, and these two guys, they are two of the most distinguished professors in the world. This is John Danesh in the middle from Cambridge University, and Timothy Spector from King's College in London and St. Thomas. So I'm actually really proud from what they have written about us on our web pages. Thank you. And this information you will find on our web pages, vitas.no. You will also find a long list of publications where the employees of the company have published papers, and you find an even longer list of publications where we have done the analytical work. And since we have been in operation for 30 years, and we have about 1,000 projects each year, this list is very, very long. We also have a list of methods, applications that we offer. And this list is about 630 methods now. These have been developed in-house over these 30 years. And some of them we use every day, some once a month, and some every 5th year, depending on the need. So we have a lot of customers. So these are the logos of some of these companies that we have been working with the last years. So you will see a mix of Ivy League universities and big and small pharma companies. One company is not on this list, and this is a company we've been working for with about 12 years. And currently this is our largest customer. Any guesses? Cincino. This is you, huh? And in my company, there are about 73 workers currently. 29 are humans, and the rest are robots and machines. So the humans in my company, real humans, you know, not fantasy humans, but real humans. So these are the 14 first employees in my company, and they still work there. Something I'm quite proud of. And on average, they have 17 years experience, which is good. This guy is AI. And for those of you that hope to meet this guy in the hallway saying, hello, welcome to Vitas, when they visit us, they will be disappointed. Because the robotics, they look boring, more like this and this. So these are off-the-shelf machines that we have modified to do the work we need them to do. And this guy, the Hamilton robotic, is really important. He will prepare the dry blood spots, read the barcode into the database, punch small pieces of paper into the glass vials, and prepare for the next step, being these robotics, the gas chromatographic systems. So this team of robotics, 1 Hamilton, 4 double GCs, will handle 560 samples per day. And currently we have 4 of these Hamiltons, and they will then feed 18 of these double GCs. And then altogether, this actually makes up 36 single GCs, because each double GC is equal to 1 single GC, which is the normal kind of setup. So in total, this team can handle 2,500 samples per day. So this is 50,000 per month. And then, if we look at the historical development of incoming DBS samples for fatty acid analysis from Cincino, you can see that from the start in 2013, there's been a massive increase. In 2016, it was 50,000 per year, and hopefully this year we will reach 250,000. So that is a 500% increase in 8 years. That's pretty good. And if we forecast 10 years ahead on this historic development, I think it's likely that you will reach at least 600,000 per year in 2034, or maybe the double. I mean, if you ask Örjan, he would say 10 times, I guess. But, you know, how can we prepare? We need to make sure that we are prepared for this growth, right? So then we can easily increase by copy-pasting what we already have in the lab. And for instance, we can have 72 GCs and 8 Hamiltons. And we will be able to do 5,000 samples per day, or 100,000 per month, which is 1.2 million per year. So then I will switch to talk about the assay performance. This is of course very important. And assay performance is how well is the test performing, the service performing according to the needs. Before we can do this, we need to define the purpose of the service. So what is the purpose, you know? And using vitamin D as an example, I would say the purpose of this test is to determine if someone is deficient in vitamin D, being in the low red region. Or if they are toxic, they have toxic levels of vitamin D in their blood, being in the high region. So it doesn't really matter if it's 300 or 400, you know, because you're still too high and you need to stop taking supplements. Of course, people need to know if they are going from 50 to 100, but it's not important to know if you are 72 or 74, because it's the same, it doesn't really matter. So to check this and monitor this, we use something called quality control samples. And I talked about this yesterday during the panel. So these are dried blood spots looking like this. We make them from like 20 liters of blood, have them in a big bucket, we mix them well. We make tens of thousands of dried blood spots, and we dry them, put them in the freezer, and every time we do the analysis, we use this to monitor, for instance, the precision. So this is how similar are repeated analysis of the same sample. So every time you send us samples, we put some of these QC samples before and after, and then we put all the data from the QC samples into a control plot looking like this. You can see all these dots, they are results, and this is how it should look, like a sound variation around the green line, not any trend going up, going down. But if you see something like the extreme there in the blinking blue ring, we need to check the calculations. If you find something wrong, we can correct this, and then we can upload results to the servers. If you don't find anything wrong, we need to reanalyze all the samples, being about 150 samples. And this is why we need a second ring, the B sample. This is the QC plot for one of the fatty acids in the balance test. So this is C16. It's a very abundant, common fatty acid. And you can see the relative standard deviation, the RSD, is very low. It's 1.9%. Looking at EPA being at slightly lower concentration, you can see that the RSD is slightly higher, 7.1%. And then I will switch to talk about accuracy. So accuracy is really important. So how well do the result compare to the true value? And there is a number of ways to do this. One way, again, vitamin D is an example, is to isolate the plasma fraction from the liquid blood, the yellow on the top. And then we can do vitamin D analysis on this fraction and compare it with the dry blood spot result. And this is what's done in this regression curve here. And you can see that the result giving a 100 in plasma fraction also gives 100 in the DBS sample. So it's high accuracy. Another way is what I mentioned yesterday, is to use certified reference materials. These are samples, freeze-dried serum coming from an external source. They have a certificate with a true nominal value. And when we use this to calibrate all the assays, we know that everything downstream of this can be traced back to this nominal value. So this secures the accuracy of all the assays. Then we can then calibrate. We can use a pool of whole blood, liquid whole blood. We can separate the plasma fraction, and we can define a value of the plasma for this 20 liters of blood. And then we make dry blood spots. We can use this with a known value to calibrate the DBS assay for vitamin D, and equally for all other assays. In addition, what we do is to participate in external quality assurance programs, like DCAS. And when this program has criteria, and if you are within the criteria of this program, you are regarded as fit to perform this service with sufficient accuracy. So this is our proof. We have, thank you. Similar we have for HbA1c. So these are SRMs for HbA1c from a party called DEX. We have low, medium, and high concentrations. And when we do our methods on these reference materials, you can see that the accuracy is between 102 and 106%, meaning 2 to 6% from the true value, which is high accuracy. We can also compare with external labs, like this Swedish hospital being the reference lab in the Nordic countries. 264 samples measured in the Swedish lab as liquid blood, the same sample measured in Vitas as DBS, and again, you can see 6% is 6%. We also participate in round robins, external quality assurance programs for HbA1c. The expected value under the red arrow, 40.9, what we find, 42 and 41. High accuracy. So another important thing is stability, and this is especially important for a service like DBS, collected all over the world and sent to our lab through normal mail. So vitamin D is very stable. You can see 3 persons, 21 days at ambient in the bag that you ship the samples in, almost no change over time. Same for 50 degrees, no change over time. And then for fatty acid analysis, we do something called a mail-back test. We prepare DBS samples from 15 persons. We analyze them straight after drying, 2 hours. We send them in the mail to employees. They send it back again, put them in the freezer, in the fridge for 3 days. So in total, 10 days transport. And then we do a second analysis, the orange bar. So the blue bar is the first analysis before shipping, and the orange is after 10 days. So you can see is very similar, both for the ratio and the omega-3 values, stable. So do you think the service is fit for purpose? I agree. Okay, so we do have top quality, we have sufficient capacity, but we need to prepare for the future. So how can we make sure that we stay ahead of the competition? Well, I think we need to stay agile, you know? We need to be unique. We need to innovate. We need to grow and expand to different parts of the world. And we need to maintain sufficient capacity, but never lose the high quality. But at the same time, I think the service and the new services need to be meaningful to people, improve their quality of life. And I think one way to do this is to fight diabetes. Because, you know, diabetes is a pandemic. It's 560 million people in the world with diabetes today, and it's increasing dramatically. And this high blood sugar will react with different parts of your body and cause diseases like coronary heart diseases and dementia, but also diseases to the eye, like cataract. And then I think it's pretty fascinating that the same red blood cells that we use for the balance test can also be used for HbA1c. So glucose will react with hemoglobin, the red color of the red blood cells, and form glycated hemoglobin. And by taking a few drops of blood from the fingertip and study this reaction, we can tell if a person is healthy or have diabetes. And I'm really, really happy that Cincino decided to launch a product for this test. Because if you're below 38, you're healthy, right? And if you're in the yellow region, you're in the risk of developing diabetes. And if you are above 48, you are by definition diabetic. And this brings me to my final part. And this is why I work with Cincino. And this is why I continue to work with Cincino. So you've seen that we do important work. You know, we work with premature babies. We develop new drugs with our partners. And that we publish these in really high impact journals. But do you read these scientific papers?
Yes.
I mean, most people don't, you know. So I think this guy, Goethe, said something really important 200 years ago. He said, it's not enough to know, we must apply. And for me, the collaboration with you, with Cincino, is applying the knowledge that we generate as researchers, as scientists. And I think this, you know, teaming up with a commercial force like Cincino, being global, with thousands of people out there every day with a message, this is the way to do it. And with this test, the diabetes test, we can identify people with diabetes and we can change their lifestyle and we can reverse the disease, because 100% of all type 2 diabetes can be reversed. And in this way, we can save lives together. And I'm a scientist, you know, so I like to have data, I like to have proofs. And this is my proofs. This is the 15,000 first test that you guys did on diabetes. And every dot here is a person. And you can see the ones below the orange line, they are healthy. The ones between the two colored lines, they are pre-diabetic. And the ones above the color line, they are diabetic. So 73% are healthy, 22 are pre-diabetic, and 746 are diabetics. So in my opinion, we together saved at least 746 lives, maybe 3,500 lives. And if you add up the diabetics and the pre-diabetics, this is 27% of the cohort. This is a lot, you know? And if you do 1 million tests, you would save 48,000 lives, or 220,000 pre-diabetics. And for Örjan, if you do a 100 million test, this would be 5 million diabetics and 22 million pre-diabetics. Think about the number of lives we can save together. And I really, really think together we can make a difference, We can do science together. We can do crowd science. And this is how I think we really can stay ahead of the competition. So this is why I work with Cincino. Thank you.
Thank you, Thomas. It's such a